Hello, everyone. Good evening to everyone who's in India. And thank you all for joining us today for this event, which is going to be hosted by the ad company. And they're going to be talking about their aim and how they're going to be flipping the internet. It sounds very catchy, but they're going to be telling you behind the scenes of what it actually means. How do they plan to do it? What does flipping mean? I introduce you to the speakers for today. They're going to be Barbara, ma'am. She's a co-founder and CEO for the ad company. Kevin, sir, who is a co-founder and the chief product officer. Along with that, we also have Colin, sir, who's a co-founder and chief technology officer for the ad company. The stage is all yours, and we would like to hear everything about how you're planning to flip the internet. Thank you.
Great. Good evening and welcome, everybody. Thank you so much for joining us. So let's talk about why the internet needs to be flipped first. So Colin, can you show the slide of how the internet works today?
Well, I can. This is us, apparently.
There we go. Okay, so this is the way the internet is set up today. So everybody builds an app and then they build a database to store all the data. And you as a software developer have to protect that data. You have to store it. You have to build out how it's gonna scale over time. And it costs you a lot of money. And it's also not good from a privacy standpoint for the person. And then the person has to go to all these different apps and update their data and keep their data up to date. So you as a person, it's up to you to keep your data up to date in all these separate databases. So if you think about it, nobody would architect a system this way. So that's why we think that the internet needs to be flipped. So we are flipping that on its head. And so the person has their own database and they own the data and the apps log into the person. So all the apps are peer-to-peer, and you as a software developer don't need to build out that whole back end. And so it saves you time, it saves you money. And from the person's standpoint, there's no duplicate data anymore. They just decide who they share that data with, what applications they share that data with, and for how long. And so they have complete control over the data. And so this makes it completely compliant to all the privacy legislation that's coming out there that you would need to worry about as a software developer. You don't on the app platform. So this is the flipped internet. Colin, Kevin, do you want to talk a little bit about how the company started?
Go ahead, Kevin. Your turn.
Now you go.
You go.
Alrighty. So this started, I guess, sort of separately 15 years ago or so, maybe more, where we were both trying to think of ways to fix this problem, which is the problem is that everybody else seems to think they own your information, and I think I own my information. So we wanted to kind of fix that, we'll call it a point of confusion. So we were looking at different ways. I actually built something back in 2009 called All About Me, which was first attempt. It was actually pretty cool. But anyway, so we were talking maybe 7 years ago, 8 years ago, and saying, well, let's actually do something. And we were trying to figure out what we could do. And so it started off with we had typically in Silicon Valley, a cup of coffee, and we were just talking about stuff. And so we had our first kind of aha moment, which is if you look at the quote unquote identity problem, which is part of it, and people look at identity in different ways. And the current thinking at that point, and even today, is that your identity is a combination of a bunch of stuff all through, call it your digital twin or whatever you want to call it, but all this information about you that, in aggregate represents you, and that becomes your identity. And so you have to prove a lot of different things in order to establish an identity. And so we said, and we can't figure out who actually said it, but the question was, well, what if we did the exact opposite of that, hence flipping the internet? So what if we just flip that on its head and said, well, let's, instead of doing all that complicated stuff, what's the simplest possible thing you can do to assert an identity on the internet? And it was, holy crap, it's a unique string. And so starting from something as simple as a unique string and then building a protocol around that, or a means of expressing, the semantic meanings on top of that utterly simple thing, is really the genesis of it. So I'm going to stop and hand it over to you. So you can go ahead.
So this is 7-8 years ago. Kevin and myself shooting the breeze over a cup of coffee, and as always, Kevin always challenges you, and the challenge was go write some code, because talking about it's one thing, actually writing some code's another. So we actually did write some code, and we joined together two existing technologies. One is DNS, which is a sort of well-known naming system on the internet. It translates human readable things that you can remember into IP addresses. So pretty good namespace, and some blockchain technology, which was pretty hot back then. And we got it working, but we knew for certain it wasn't going to scale. We hit all sorts of architectural problems. And there's 30 plus companies trying to do that at the moment. And we know they're all going to fail because we failed. They just don't know it yet. So we essentially gave up because we just didn't think it was going to work. Fast forward a few more years and another cup of coffee. I was having a horrible time at a company, and Kevin was the end of the contract, so we decided to have another cup of coffee and decided we need to have another run at this idea, see whether anything had changed. And two things had changed, and the first one is very interesting. So the mobile devices that are in your pocket are now so powerful they can cut their own cryptographic keys. So if you could cut your own cryptographic keys on your own bit of hardware, you don't need a server to do that. Then that means you can own your security. So that's a fundamental bit of technology that we're reliant on, is people being able to cut their own cryptographic keys on their own device. That means that nobody else can see it, which means you can provide end-to-end security. The other thing that we needed was a directory, and obviously originally that was going to be a DNS, but we hit a whole bunch of problems. We still love DNS and we use DNS a lot, but what we really wanted was a directory server, and that meant we needed a ridiculously large scale database that could handle that. And in the intervening years, the Redis team and others had designed in-memory databases. So we had the two new pieces to the puzzle, and all we needed was some glue to join those things together. And I knew that I'm a network and security guy, so I was trying to convince Kevin that it's definitely we need a network protocol. He's always been an API guy, but I'm a network protocol guy, and we need a protocol that can handle the glue. And so again,
yeah, you were absolutely right, and I was absolutely wrong.
So Kevin challenged us to write a protocol. So he started at one end, I started at the other, and the hope was to meet in the middle. So how did we do, Kevin?
Yeah, well, we typical for startup, we start with the simplest possible demo of the most basic thing you could do, and then that sort of takes on a life of its own and grows and morphs and changes over time, and as more people come into the team. Yeah, so it's an amazingly cool and fun process, actually.
So this is what we came up with, was a protocol that could join, and famously, whenever you're talking about network protocols, there's always Alice and Bob talking to each other. They're quite famous. So if you ever start working on a protocol, then you have to include Alice, Bob. Sometimes Eve turns up to eavesdrop the conversation. There's absolutely no point for Eve because we've got end-to-end encryption, so Eve can't actually see anything. But at a very high level, this is what's actually going on at the protocol level. Everyone has a unique @ sign, so Kevin already spoke about that. we didn't know what to call these things at the beginning, so we called them all sorts of silly names. But we came across the word @, and that's what they are. All it really means is a unique string of characters. And a unique string in our world at the moment is Latin characters and emojis. However, the protocol itself doesn't care. It's Unicode aware. So we will open up new character sets as the demand increases. I'm sure we'll see more and more character sets. We start with Latin because I'm only an English speaker. Kevin isn't. I don't know what Barbara. Do you speak any more languages, Barbara? I'm not sure.
A little bit of Spanish, and that's it.
There you go. So we're all comfortable with Latin characters, but yeah, and it took me to Greece. Take me anywhere outside of a Latin character world, I'm stuck. And names are important, so that's where we are at the moment. But I'm sure that will change. Every app is peer-to-peer. Every @ actually has its own microservice that can be hosted anywhere on the internet. And very, very important to us, everything is open source. What you see in our repos is what is running in production. There is no secret repo somewhere. So, Kevin, why was open source important to you?
Well, so I think open source is taking over the world. I mean, I think it's important to everybody. But in our particular case, we wanted this to be used everywhere. So we started off with this notion of, we can apply this to people, entities, and things. So people is what you kind of see in the picture here. Entities, could be, at IBM or at Microsoft. So it could be a company, or, Colin's case, at Rotary Club. He has a Rotary Club he's quite active in. So it could be any, person or company. Those are pretty interesting. What's also super interesting is things. So the Internet of Things, which we thought was going to take years to take off, is actually taking off in a huge way with the app protocol right now. And so, we need a way of dealing with, in fact, we were just talking about this. So we said we scoped it out to be, 50 billion endpoints is what we would have to manage. And I think we guessed that way low. So my prediction now is it's going to be a lot bigger than 50 billion. But anyway, so but the notion is that at Alice, instead, with her own data and microservice, then she has the keys to the data. That's for authentication keys and encryption keys. She owns those. They're on her phone, and through some clever magic can be on more than one device as well, but on her phone, on her laptop, on her tablet. But she owns them, and so and Bob owns his keys, and so the protocol allows Alice to store some information on her phone, for example, and say, okay, I want to share this information with Bob, and then it gets encrypted just for Bob, and the only person in the universe that can decrypt that information is Bob, and we make sure that the information goes only between Alice and Bob. So nobody can surveil it, nobody can snoop it, nobody can copy it, and the keys are on the device and stay on the device. So no matter what, there's no way that we as a company who's operating all this stuff can see the data. It's just not possible. And so we wanted to make it provably true that we can't see the data, and therefore, chances are that nobody else can as well. But it's really simple. All you have to do from a developer's perspective, and this is why Colin converted me to protocols. So Alice just stores it on her phone, and that's it. And then the protocol picks it up and routes it to Bob, and looks up Bob's public key and encrypts it for Bob. So that's possible with a protocol. It's not possible to do that with an API. Well, it'd be hard to do with an API and kind of pointless. But protocols are amazing for doing that kind of interoperable exchange of information. And again, it doesn't matter if Alice is a IoT device. It could be streaming data from a video camera or web camera, or it could be some machine in a power plant somewhere. But the key is that the endpoint Alice or temperature sensor owns their own keys, and then and the protocol allows you to exchange information between those two endpoints. So that's why everybody owns their own database, and we provide that for free. So that's a service we provide, is allow you to store that data in the cloud. It gives you not only a rendezvous point, so if you have more than one device, then you can synchronize your data, but also means if you're offline, then you can still communicate and so on. Those are super, super tiny services, and we work really hard to make them super tiny so they're very inexpensive and we don't have to charge people for them. So we take on that responsibility, and that's an ongoing thing. But good news is that disks are super cheap, so storage is really not a problem at all. Bandwidth is more a problem, and RAM certainly is a problem in these little tiny services, which are super tiny. And I'll let Colin talk about how tiny are they.
So currently, it depends on which processor you're running on it, but we're talking probably about 5 megabytes in terms of the size of the binary, up to about 11, depending on which processor you're using. So very
5 gigabytes, Colin?
Megabytes, Kevin.
Yeah, megabytes. Okay.
And everything's written in Dart. We've been riding the wave of Dart since the beginning of the company, and more recently Flutter. And what Dart allows us to do is to run a single code base on multiple processors or endpoints. So one of the challenges that we set ourselves was we had to run on a light bulb all the way up to a big server in the internet, and Dart allows us to do that. At the beginning of the company, we were actually trying to decide which language to write in. Kevin and myself really don't care which language. I mean, it just doesn't really matter. We have to use the right language for the right problem. So, classically, if you're going to write a protocol, you're going to write it in C. Why C? Because, well, that means you can run it anywhere. However, if we were writing this in C, probably Kevin and I would still be in our garages bashing on code because C takes a very long time, and there's just no way we could get it out the door fast enough. So we were told about Dart and Flutter by a friend of mine over in New York, Richard, and we said, well, we'll do the demo code in that. So we did the demo code, and we never got off. So that's sort of what happened there. And if you haven't used Dart or haven't used Flutter, then you should really give it a go. If you're looking at repos, pretty much everything I'm writing at the moment is in Dart. Even the backends, a lot of that stuff is in Dart as well. One thing I need to point out is we found out very quickly, actually, through our intern program, that although I'm very fired up about protocols, and Kevin is now, as a dev, you're probably not interested in protocols. So we needed to make this far easier for developers to actually write their applications. And you can see at the top of this slide, it says the app platform. That's what we've written around the protocol. And the app platform essentially makes all this protocol madness invisible. I've seen in the chat, we often get likened to blockchain. No, there's no blockchain here at all. It's just boring protocols and boring cryptographic algorithms, very standard ones, RSA and AES. Why not blockchain? Well, as I said before, there's some fundamental problems. One of them is that it's immutable, and I don't want my data to be immutable. That's probably not a good thing. And I don't want it in a shared database. I want it in my database so I can share it out. And change it. If it's immutable, that means you can't change it. And I do change my address every so often, so I don't want that sort of locked into a ledger. So what's the simplest way of abstracting all this so that a developer can deal with it was really a big challenge? And what did we come up with, Kevin?
Yeah, so it's a simple key value pair store, and you just save some data onto your phone and say, share this with @Bob. It's as simple as that. So we've made a ridiculously simple SDK. The SDK will then notify @Bob's microservice that there's some data that it can go pick up and read. And then Bob's microservice can read it. And then on Bob's phone, it can be decrypted and used for whatever purpose they want it, whatever the app is intended to do. But it's as simple as just storing a key and a value, which is basically a string representation of both. And it couldn't be easier to be able to deal with data. And how you do with that, you can do JSON documents and have dense, large document type data, or you can have individual records. That's really where, from a software development perspective, you kind of have to wrap your head around those things of how you create some data that's intended to be shared with somebody else. And there's some, I would say there's some actual Colin clever magic in there for how do you share information with a group of people. So I'll leave that for the student to go take a look at. But there's some clever bits in there as well. But yeah, absolutely zero blockchain. We're not trying to burn down the planet's electricity grid. And everything runs on a phone, or as Colin said, my favorite test is, can you run it in a light bulb? And I don't think you're going to be running blockchain on a light bulb. So that's the way we built it.
Yeah, so we've got lots of folks running the software on things as small as a Raspberry Pi. You can run it on a very, very small Raspberry Pi. I was looking for one here. That I've had it running on this actually last night. It was running on this little tiny bit of hardware, so it runs quite happily on very, very small machines. So one of the things actually we've been doing is going through our repos and making sure that they're really easy to use. So you'll see one of the simplest one is the Snackbar demo. That's actually open on my personal repo, and there's a few challenges for the OpenForce folks to look through. But you can see how simple it is. It's maybe 100 lines of code, and you can make something appear on somebody else's phone. It's quite amusing. Like, how did that happen? I didn't actually do anything to send anything to Kevin's phone yet. Something I'm doing is affecting Kevin's phone. That was one of our original aims. It was a lot of fun getting as far as we can, and we've had a huge amount of help to get as far as we have with an amazing dev team and open source community. So one of the things that Kevin in particular is very, very keen about is widgets. So we should explain what widgets are. It says here pre-built widgets. So what's a widget, Kevin?
Yeah, so those of you who are Flutter developers, and if you're not, you should definitely check out Flutter. It's taken over the world. So Flutter is super cool because everything's a widget. I mean, basically, as they describe it. And so so when you build something, in fact, we have a command line utility called AddApp that allows you to build an app skeleton with integrated widgets in seconds. And we're building out lots and lots of widgets that makes it easier for people to say, I want to add chat into my application, and you could just import a widget. It has screens already that you can customize, but it'll get you 80% there to add that feature into your app, and then you can just make sure that it performs and looks the way you want it to for your app. So widgets are a huge ability or a huge feature to go faster in development. And that's Dart's the language, Flutter's the cross-platform framework, runs on anything, including now desktop apps. If you want to build, you can do mobile and desktop in one code base. But that's just part of it. I think there's a lot of this is we sort of optimize the platform to help developers do less and get more. So Barbara, do you want to talk about why that matters?
Sure. So as I said a little earlier, you don't have to build the whole backend that you have to today. Normally people use Firebase or something like that, and then end up storing all that data. So you don't have to do any of that work on the platform. We host all that for you. And so, there is no backend. There's no one database holding everything. And you don't have to build out the key management, which is really hard if you're trying to build end-to-end encrypted apps. That's just really difficult stuff, and that's all handled for you, as well as there's no usernames and passwords. And this is huge for me because my last company, 90% of my support was usernames and passwords. And so just to have that taken away is awesome. So it's also faster development, as Kevin was talking about the widgets. You can just put together these widgets and come up with an app really quickly. And Flutter's just amazing. You can create a really nice looking app with very little effort. And you also get automatic privacy compliance, which is huge. You just don't have to worry about taking care of people's data. That's all done for you. You save on the infrastructure, and you can do more creative things because the apps are actually peer-to-peer. So Kevin, do you want to talk a little bit about like the Buzz app and how creative?
Yeah, sure. There's a question in the chat as well. It kind of relates in terms of how you're sharing data. So Buzz is an app. It's one of our favorites. Has been for a long time. But so Buzz is basically a completely new vision for what's probably the worst app on your phone, which is the Contacts app. And it's the worst app on your phone because all the data there you have to maintain about all your friends and contacts. It's always out of date and it's always incomplete. So I don't know how many people I have in my contacts database that are, maybe a phone number without a name or any other information. It's just a phone number. It's like, what am I supposed to do with that? Because I don't even know what it is. But I can't be bothered to go take the time to clean up all that kind of stuff because it's just such a mess. So this flips that, again, flipping the internet. So what if the information that Barbara sees on her phone about me is information that I control? So I decide what Barbara can see and do about me on her phone. And so what that does is it puts me in control of the information, and I decide what I can share, and I share things very differently. So it also includes this notion of a persona, and the persona would be like my work friends and my camping friends and my in Barbara's case her dog friends, because she's a huge dog trainer, and so it becomes very social. It's not just phone numbers and emails; it's pictures and updates and that kind of stuff. So it starts to become more social, which is very interesting. But that's just for contact information. But the key thing is that if so the protocol includes a number of controls, and they rely on both ends of the wire honoring those controls. So if I share information with Barbara, I have the ability to delete it or change it or share it for a certain period of time and then take it away. So that the protocol provides that capability for controlling modifications, deletions, and even delayed access. So those are all defined within the protocol. You rely on both parties doing that. So it would be possible for somebody to ignore that and make a copy or something and keep it surreptitiously. So our strategy on that is just to make it really easy to comply with that, and rely on, in the end, on to back that would be legislation. So if a large corporation says, I'm going to ignore that and keep the information that you've explicitly said that I no longer have access to, then they are liable for lots of nasty penalties and fines and that kind of stuff. So in the end, it becomes backed up by legislation, but we make it really easy to comply. So as Barbara said, automatic privacy compliance, we so overachieve on things like GDPR, it's not even funny. So we go way beyond what the requirements are and make it really easy for people to comply with those. And so that's our strategy, and we think it makes sense.
So how to get started? Well, as we mentioned, everything we've written is written in Dart, and they're using the framework of Flutter. So if you look at our repos, you'll have to get to grips with Dart and Flutter without a doubt. And the good news is it's really easy to get to grips with, and there's some really good content on Dart.dev and Flutter.dev and @sign.dev on how to get started with all these things. And there's also a place where you can look at all the published packages. I think all of our packages now on pub.dev. Kevin, is that right? Yeah. So all of our packages there, and they're also all the source code's obviously open source, and it's on our GitHub repos.
Yeah, even our website, our dev site is @sign.dev is also open source. So we tend to open source everything.
Yeah, feel free to contribute there as well if you see errors, or you think you think you could do better. That would be awesome. One thing we love as a company is PRs. So if you see something, do something, even if we haven't marked it. So we do have actually two of our colleagues gonna join us and run you through exactly which repos are available to contribute to. So Jalin and Shubhangi.
Thank you so much, sir and ma'am. Here we have with us Jatin and Shubhangi. They're responsible for the DevRels, as well as Jatin also works on the product with the ad company. The stage is all yours.
Thanks, Vidushi. So, I'll just take you through what apps we have for you people here at OpenForce. So the first one is our @Wavy app, and I hope I'm audible. Yeah. So the first one is the @Wavy app, and it's like a web page, I would say, where you can add any of your details, and it can be about your business, your projects, or about you, or maybe something cool like about Spider-Man or Batman. So you can make a wavy page about anything, and my wavy page is called @Friendly Madagascar. So go ahead and check that out. So we have really cool wavy pages that you can make. And the catch here is that you control all your information. There would be no ads on the page. It's all yours, completely yours. And the second thing, as Colin mentioned, is the our dev site. So here we have all our documentations and anything that will help you build. But you can improve this as well. So something that's helping you build, you can improve that as well. So that's the best part here. And we have 2 more repos that you can contribute to, and passing it on to Jatin.
Thank you so much, Shubhangi. Hey, folks. Thank you so much for thank you so much for listening to the kind of amazing vision that we have behind the product. And I love working on the feeds here. So you have heard about the amazing stuff that you can do with Wavy and also @sign.dev. But there are 2 more projects that you can contribute to for this organization. First, that we have Snackbar, and then we have CatWeb. So basically, the name seems to be, like little interesting to you. Like what the kind of thing it is. You can see the interface here. Let me first tell you about Snackbar. Snackbar is a really simple app that we have developed on the ad platform. You can see Colin here has his own repos on Snackbar and CatWeb, and there are some issues listed with the OpenForce tag that you can go and start working on contributing. Snackbar is a really awesome app built on ad platform where you can actually send a snack to your friend by just using the @sign. That is also the global individual identity. I think you have heard a lot about the @sign thing, and that's the power. Like you don't need the kind of data, because again, let me requote, we love the internet, and that's why you don't need anything else. You can just use Snackbar to share the same a snack with your friends and anyone with the @sign. And then we have CatWeb. So CatWeb may seem like a IoT project or something. So let me tell you about CatWeb. It's a really catchy and interesting one. With CatWeb, you can use the near real-time frequency and modulation mode being used to a website. So like for other operators, you know where you are listening to. There are no firewall ports should be needed to be opened. All data is actually encrypted, So one thing that you have heard talking about is, we don't want your data to, we don't want you to be generalized with your data. We don't want to share your data everywhere else throughout the internet, So here you don't have any risk of that. So, you can use the same thing, but without a fear of the data leak. Everything is encrypted here. So we have these two more amazing repos that you can use and contribute to. And apart from it, there are more things that you can actually look up to, because we are not limiting you to work on just one person per issue. We have seen a lot of these things on our GitHub, and we have been tackling the questions there, but you are totally free. We at that company don't want to limit you to your creativity, to your vision. People are actually coming up with some really amazing stuff on our repos as well. So please feel free. Multiple people can work on single issues, and they can actually make some more awesome changes here. And yeah, that's it. Thank you so much, and pass on to Vidushi.
I'll do a quick demo of CatWeb so you can see it running. How about that? This is very impromptu, but let's do it anyway. What could possibly go wrong? It's a demo. It's likely to go wrong. So
we did not prepare for a demo, but there's a request for a demo, so we'll try.
This is CatWeb running on Windows. So this is a Flutter application running on Windows. It doesn't actually have to be mobile. Although interesting, it's exactly the same code. And if I may have another camera here. Let's see. This is very impromptu, but let's see. See what I can share my camera. Settings. Camera. Yeah, look at that. Do you see that? I think you do. So this is a ham radio. This is an IC7100 ham radio. And you can see what frequency I'm on. This is the frequency here. This is in megahertz. And I can change the frequency. So, and you can also change the operating mode. These are the operating modes. So there's single sideband, constant wave, RIDI, FM. So for this particular frequency, you're probably using single sideband. Ham radio operators are generally old grey people like me. However, more interesting, over the last few years, lots of drone operations and need ham radio frequencies. So you'll find lots of ham radio folks are actually also drone operators. And what this particular radio allows you to do is speak to people all over the world. However, they need to know what frequency I'm on, because if they don't know what frequency I'm on, then it's just there's some random collision as to whether you're actually going to meet somebody. So if somebody wants to speak to me, or if I want to speak to somebody else, then it would be really cool if this radio could communicate to a bit of software, and that software could advertise on the internet what frequency I'm on, so somebody could come find me. So you'll see as I change the frequency here, if I change it to 7.40, you'll see CatWeb's automatically being updated. It's actually making a connection to the radio using CatWeb. And so now CatWeb, the application, knows what frequency I'm. I am a bit of a ham radio nut, and you can see I've got lots of other radios. I'm just using the top one. These other ones actually, I think actually this one's actually activated. I'm trying to click on the screen here. I've got to click here, and you can see it pops up. This is the frequency I'm on. I could activate that one as well. I'm not sure whether that will come up. So I can see these things. I can add another radio. This, also this is all written in Flutter, and this has been updated. But this is running on my machine. This is not very useful for somebody else knowing what frequency I'm on. What it really needs to do is actually speak to a web page. And what we thought was it would be really cool if you could actually speak to something particularly at. And so here's a web page. And it's my Wavy page. You heard Shubhangi talking about Wavy. This is at Wavy. Everybody in the ham radio world has an @ sign. This is mine, AI6BH. And you can see down here, there's a little panel saying, I'm listening on my IC7100. So this web page is being updated with the information in near real time. So if I change frequency again, if I zoom down to 267, you can see CatWeb knows it's 267 now, and it will communicate via the power of the app protocol, and magically it will update on the web page. So all my ham radio friends just need to look on my Wavy page and see what frequency I'm on. You also notice I'm not actually hitting refresh on this website, so I've changed it to 27274, and there we go. It's updated. I didn't hit refresh, didn't do anything, and that's because this is actually a Flutter widget. You heard Kevin talk about widgets. This is a Flutter widget embedded in a web page. Flutter has this, Flutter has this neat trick of being able to compile to binaries like CatWeb. This is a binary file, but you can also compile into JavaScript, so it can actually run inside a web page. So that's what's going on. And I'm not going to demo anymore, Kevin, because everything worked, and that never happens in a demo. So
I only have one question for you, Colin. So that's a lot of radios. Are those? How many radios do you need?
Well, the perfect number of radios is just one more. That's the absolutely perfect number of radios. Yeah, I definitely have way too many radios. I can't help myself. But anyway, it's a very fun hobby. If you don't know about ham radio, take a look. It's an amazing fun hobby. People have been in it for. I mean, people that have been into the hobby for decades and they still haven't scratched the surface. So CatWeb just adds to that extra layer. You can be a software developer, an IoT developer, and there's a whole bunch of things in CatWeb that I've asked people to help with. You can see at the moment that everything is sort of very green. It'd be nice if these displays were different colors. Maybe somebody likes orange. So that's one of the challenges. To get rid of this green sort of flavor and have a drop down maybe here where I've just got closed that says pick a color. Lots of ham radios actually have orange rather than green. I prefer green, but other people might prefer orange. So that's a challenge. Jadin, I'll stop because everything worked.
Okay. So we don't just have repositories that you can contribute to. We also have some really cool T-shirts, and this one's a Star Wars themed one. May the source be with you. So you can complete a few simple steps and participate in a T-shirt giveaway. So you're contributing to open source and getting some really cool T-shirts. So it's like a win-win situation for all of you here. I think the next slide. Okay, I can talk about this. I think we also have some summer internships here, I guess. So you can just go to our website and check out these opportunities that we have for you. And I think that's about it from my side. Over to you, Vidushi.
Yes, I think that was very, very informative and insightful for all of us, because I see a lot of folks have been confused about what the product is, how does it work, what is flipping the internet, and I think they're very curious to know more about it. And I think there would be a lot of PRs now. Plus, the giveaway has been quite tempting for all of us, and I mean, everyone looks forward to contribute to the ad company. Other than that, I'll leave the stage for a Q&A. I see there was one question by Ayush, which says, we usually log in through Google or some other social auths. So how can we use ad platform there? To prevent those companies from accessing and storing data.
So fundamentally, auth and sharing data is two different things. So it's technically possible to log in through Google, although just that act itself, you're now sharing a bunch of data just by doing that inadvertently. So the So the short answer is we recommend not doing that, because the way that you do authentication is very different. So it's, and what are you logging into is the question. So if so what's interesting on the app platform is that both sides are authenticating to each other. So when you share information using the app platform and the app protocol, both sides are proven to be who they claim to be. And that's not possible. Usually Google is you proving to Google that you are who you claim to be. We want people to prove that they are who they claim to be. So if I'm sharing sensitive information with you, I know exactly who I'm sharing it with. And that you can't do with Google, at least not today. So that's the way it works. We are looking at, just if you want to use auth, doing kind of more of a middleware implementation. So you could do the use case one developer is currently working on is, I want to share pictures with my friends in a Facebook app that they want to build. So they have to use Facebook for authentication for Facebook. So how can I then, on top of that, build, I think exactly as the question stated, how can I make sure that Facebook can't see the results? So we're working on that with him at the moment. And that's what we call middleware, the middleware kind of implementation, where you kind of blend the two. That's a work in progress. If anybody's interested in doing that as an open source activity, just let us know, and we're happy to get your help. I mean, it would be awesome, because that stuff never goes as fast as you want. Colin, what did I miss?
I think you covered it pretty well.
Awesome. That's great. And I don't see any other questions here, but folks at OpenForce, all of you are open to send in any doubts regarding the giveaway or the open source contribution in the Discord channel, and we'll be happy to help you out. Even doubts regarding to Flutter, we have mentors, we have people from the ad company, everyone who's willing to help you. So the ad company not only comes with open source repositories, but also with giveaways, hiring opportunities, etc. And thank you so much, sir and ma'am, Shubhangi and Jatin, for hosting this. This has really been insightful, and I hope to have a lot of contributions from OpenForce. Thank you so much. Have a great night, everyone.
Thanks, everyone.
Thanks very much.